the name of this conference is Ruby Shift, so I thought there's enough Ruby going on, so what about the shift part, right? So we're going to shift away from Ruby for 45 minutes or so. So a little bit of information about me, because you probably don't really care who I am. These are my Twitter and GitHub account, and my name is Tom, and that's Roxy. So let's set some expectations for this stuff. First of all, this is an experience report. It's not an introduction or language primer, or I'm not going to show you anything in the REPL like Alvaro did yesterday, so probably it will be a little bit more work, but we'll see. It assumes no familiarity with Clojure except basic facts, like you probably should know that it's a programming language that runs on the JVM and CLR. Yeah, and it may contain profanity and appropriate jokes and other offensive stuff, so if this is not for you, you can leave right now. It has almost 200 slides, so we're gonna go fast. And yeah. So a little bit of background. When you choose a piece of technology, you have to understand how you're going to use it, what the trade-offs are, and let's start with seeing what I have used Clojure for. Yeah. So I do quite a bit of data processing. I know it's a broad term, but I unfortunately cannot figure out a better way to put it. So just you have a bunch of data, and you need to produce more data from it. It's that simple. So I develop things like scheduling systems, so they have a lot of time going on, and they are not really much like, you know, traditional web applications, for some definition of traditional. I developed specialized web crawlers, so again, it's not, it does have something to do with the web, but, you know, still pretty different. And then things like building accounts, and again, you usually don't render much HTML. So, at some point, I thought that, okay, I have a number of years of experience with Java. I have been using Ruby since 2006 or so. And honestly, I don't like either of them very much. They're fine. It's not a torture to use them, but maybe there is something that combines the strengths of them, right? So, something that I personally and my team wanted to use. An environment that doesn't suck. Like, that's not very specific definition, so let's clarify a little. That is operationally sane. Because things tend to, you know, sometimes break, I think, in the middle of the night. I don't want to spend that middle of the night in a GDB session trying to figure out why freaking C Ruby is misbehaving. I want to have certain amount of toolchain infrastructure to help me do that. And I also wanted a runtime that, well, has decent tooling for development purposes, things like profilers, or things that collect metrics about what's going on in your runtime, and, for example, garbage collection stats. I wanted something that yields good baseline performance, and I will expand on what baseline performance means. I also wanted painless upgrade paths, because, yeah, the Ruby community, let's just face it, does not care about backwards compatibility very much. It's like every new year we have to rewrite half of our shit because a new cool library was released, or some new version isn't backwards compatible because, you know, shiny toys matter more than rock solid running systems. Yeah, I don't think like that. You want something that has a community for obvious reasons. You want other people to do work for you, right? At least I do. Yeah. You want to benefit from existing tools and libraries, again, for the very same reason. I'm so lazy that I don't want to do anything. You want your runtime to provide you concurrency and parallelism support. Because you're probably not going to convince your manager that, you know what, dude, I'm going to write a new runtime for this project. No, it's just not going to happen. You want a productive, concise / expressive language for obvious reasons. And it turns out that the closest you can get in the open source ecosystem today is the JVM. So, what about it? It's one of the most mature runtimes you can find. It is very battle tested. I don't think there are many other runtimes that are as battle tested. Well, Beam or Erlang.cp and .NET, and that's about it. Okay, maybe Perl as well, but Perl wasn't an option. So, again, it has excellent tooling of all kinds. For example, you have there was a talk yesterday about Visual VM, JStack, and JHat, but JVM itself has a lot of flags that let you control its behavior. You have a bunch of great IDEs. I'm not really an IDE person, but if I have to explore a large code base, that's actually very, very nice to have. You have things like btrace, which is, if you are familiar with dtrace, it's a very similar thing for the JVM bytecode, and yeah, it's a hidden gem. And you have profilers like PureHit and a ton of other things. And it offers excellent baseline performance. Yeah, I think not many people will argue with that. It also offers you a choice of language. Clojure, Java, JRuby, Scala, JavaScript implementations, and a bunch of other languages like Kotlin, all available for you to choose from. And the nicest part, all of them integrate with Java. And usually that's very nice because, again, I don't want to do any work. So, yeah. So, Clojure is my choice, and I'm not really trying to convince you that it should be your choice. I'm just walking through why it was an excellent choice in hindsight. Very high level, concise and expressive. Again, this is a little bit hand-wavy, but I mean, we all know that some languages are expressive and some aren't. Has excellent concurrency parallelism story. One of the design goals was to support concurrency well, provide a lot of primitives for that, and also parallelism, because it's a hosted language, right, it gets that for free. Very good baseline performance, and it is consistent and well designed, as it turns out. Because it wasn't designed, you know, by a bright student in the 90s, who probably didn't really spend much time designing the language, but instead was, you know, hanging out and listening to late Nirvana. Decent tooling, I'm kind of repeating myself, it is fun to work with. Like, okay, what's up with that yellow thing, right? Well, it was, depends how you define this function. So, what it means to me, it motivates you, because there are languages that almost were designed to proactively demotivate you, right? Yeah. In the community, there are not that many bored academics. It was built by a practitioner, even though it borrows a lot of stuff from research that sometimes goes like 40 years back. Because very few things are new in computer, quote-unquote, science. I find that a good thing. So, let's see the concurrency parallelism story. It has immutable data structures by default. There aren't that many languages that choose to go this route, but Clojure is one of them. It has identity value separation. I will, this will be a more expanded section about that. I will explain this. So, value is something that doesn't change. Imagine that as time flows and something happens, that thing no longer changes. I don't know about you, but I cannot change the past. So, if something happens, we call that a value. It's a little bit of a terminology introduction. So it is a fact. Like, for example, numbers don't change, right? Identity, it's a series of values, or basically it's like history. That's the best way to put it. For example, a person is an identity, right? The people change over time, right? And it's still the same person, this technically, by name and so on, most of the time. And state is a value of an entity at a given moment in time. So it's like a snapshot, if that makes more sense. So it's like a person in a given moment in time. So this is what it looks like. So we have for states, there are states of the same identity, and we see time flow. And each of these greenish things is around. Maybe a better way to present it is, again, the person changes over time. Still the same person, but yeah, it doesn't exactly look the same. So this idea actually just reflects how the real world works. Things are not changed in place in the real world. If, I don't know, you take someone, break it apart, the old thing is gone, right? You have maybe some new pieces. So what it gives you in the end, from the practical standpoint, is you have predictable state transitions. That's it. That's the most important part. So Clojure has something called concurrency-aware reference types, where if you're familiar with, say, in Java there are atomic references, this is one way to explain it. And there are also values that are asynchronous, which mean they are state changes, but at some point in the future we don't know exactly which one. And then in Clojure you have access to Java to concurrent, which I think falls into the concurrency story very well, and it's actually a hidden gem of the JVM. Even though it's a Java library, right? It's ridiculously easy to use. It is very well documented. It is designed, it's very mature. It's like 8 years old or so at this point. And there are many things that encapsulate common patterns with respect to concurrency. Yeah. So there are people who write songs about JUC. And again, because Clojure is hosted, because it was designed to interoperate with the runtime underneath it, you can use Scala or Jetlang or Max Disruptor or anything you want. But, for people who think that concurrency is asynchronous I/O, my advice: don't read Hacker News that often. But okay, you have choices. You have NIO, NIO2, in JDK7, Netty, Vertex, and honestly, at least 3 more asynchronous I/O libraries. So you think that Node.js is something you think again. So you have choice. That's the point. I'm kind of repeating myself. You can have hundreds or thousands of threads at the same time if you have enough cores for them. They all will happily run in parallel. So that's a great thing, I think. At least if you don't want to use that, okay, but it's always at your disposal when you need it. So, don't worry to load your runtime. It should do all the hard work. I think I need to. So, what is baseline performance? For performance, what really matters, at least for JVM languages, is what bytecode the compiler produces. Performance isn't an abstract thing. It is the amount of work that is done by a runtime. And another thing, when talking about performance, you need to know about the context. What exactly is going on? How do you use this and that? And if you don't have context, all the discussions that X is faster than Y are basically bullshit because they're not based on anything. Just as an anecdote, a joke kind of thing. There is some fellow who basically once wrote some kind of crazy Clojure code that ends up running faster than every C program that he tried. Again, maybe just his skills, but you typically won't see this in real-world systems, but you can do that. You can trick your way into great benchmarks, more or less. So this is a great site. Check it out. It explains why in technology in general, you need context to compare performance of things or just anything really. So when Clojure integrates with Java, Clojure is always compiled. There is no interpreter. So Clojure compiler compiles your code when it is loaded, and it produces usually exactly the same bytecode as Java C, which means if you trust Java C performance and stuff, if you trust its results, it's probably going to be good enough for you. And a couple of things to watch out for, like low-hanging fruits. You can watch out for reflective calls. So there is something called reflection in Java, which is basically not the fastest way to do things and usually isn't necessary, but sometimes, because Clojure is dynamically typed, the compiler cannot figure out everything for you. So it will emit reflective calls that will figure things out at runtime. That's usually not very fast. Another thing is primitive boxing. So things like, basically on the JVM there are numbers that are primitives and numbers that are like real quote-unquote objects. This distinction is largely historical, but that's how it is. And constantly turning one into another, usually it takes time at no productive work. It just wastes cycles, right? So in Clojure you can do optional type hints if you really want to help the compiler to know that this thing is of a particular type. Well, you can do that. By the way, the compiler is free to ignore your suggestion some of the time. Another thing, it has type inference, so the compiler can figure out that, okay, this thing is obviously something. I know about it, so no need for type hints. So as example, here we instantiated date and assign it to a local D. We don't need to specify the type of D because it's obvious, right? It's date and nothing else. The compiler is smart enough to know that. Basically, the bottom line is if JVM can optimize your bytecode, things run screaming fast. And I think for most purposes, JVM's performance is probably pretty good. Although, just by looking at real-world libraries and stuff, you can see that if you only have like a Java library wrapper, you lose maybe 2% you have 2% overhead. And if you have naive numerics heavy code, which unfortunately is what a lot of people do to benchmark things, you can get like 3 times slower. But for me personally, 3 times slower than Java is still good enough, because the language that is in the name of this conference isn't exactly known to be a speed thing. But people still use it, and probably pretty happy with that. So another thing to pay attention to is that immutable data structures, they are not naive copies. If you change a key in a hash in Ruby speak, it creates a new data structure, but it's not a naive copy. It's not like, hey, let's just copy everything. There is smarter stuff going on under the hood, and it has this big old complexity. It's a pretty good complexity, well, for most things. But when people first hear about immutable data structures, they usually freak out and say, wow, is everything copied? No, that's not the case. And another thing, immutable data structures have some associated garbage collection tags, so few things come for free. Performance is one of them. There is something called reducers in Clojure 1.5, which is basically a way to make sequences and collections perform operations like filtering and map and all other common functions in parallel. Again, if you have enough data in the sequence and and you have enough cores. So sometimes reducers won't make sense. Clojure in general, the Clojure core team focuses on exploiting parallelism over just squeezing every bit of performance from a single thread because, well, the number of cores is growing. Maybe it's growing slower than some people expect. I mean, by now we were supposed to have, what, 64 cores? Where am I 64 cores? But okay, 8 cores is probably better than, you know, 1 or 2. So that's where the focus is going. But in general, there's weak performance seriously. Another thing to bear in mind that it's true that JVM and Clojure in particular are not great at their startup time, but it's separate from execution performance. The reason why Clojure adds so much to the startup time, it's like 95% of a Hello World program is spent compiling Clojure 4 namespace, the standard library basically. And yeah, that takes time. That's a Java program compiling code, but that only happens once, so for long-running processes, you really don't care. And for things like development, well, people use long-running JVMs, they just submit code there for execution. There are tools that do that. Just anecdotal evidence, looking at various people around me, there are systems that were ported to Clojure and produce a ridiculous number of throughput improvements compared to Ruby, and in some cases it's pretty ridiculous even compared to JRuby, because JRuby has to do a lot more work, honestly. That's primarily why, but well, that's just how it works. So let's take a look at another thing that I really like about Clojure. It's stability. I have been using Clojure 1.3 since the first alpha, so I don't use nightly snapshots, but at first I was very skeptical, like, what's this alpha stuff? Like, how many people, raise your hand if you run an alpha Ruby version in production? Yeah, okay, not many people do that. I understand that. So, and we have hit 3 bugs in Clojure in over a year. Raise your hand if with your programming language you have seen only 3 bugs in runtime in a year or more. Again, probably doesn't happen very often, right? It's ridiculous how stable this thing. One bug is actually an edge case. I was doing something really stupid, and Clojure didn't agree that it should really do that. I filed the bug saying, what the hell, and in the end it actually was improved, and it is in master now, but yeah, I think it was more of an accident, you know, on my part. So alphas are more solid than GA releases of almost every other language I've ever used. Other people like ThoughtWorks who like go into a little bit of detail how they use Clojure report the same experience. So that must be, you know, not a miracle, I guess. So now let's talk some numbers. I've created 28 apps and libraries from 1.3 to 1.4. When that was released, I don't remember, in May or so. Just one change was necessary to a pretty finicky third-party library. The rest was a drop-in replacement. So how about that? Pretty cool. I didn't expect it. So when upgrading is easy, what happens is people do that, right? People do that happily. And what that means is the ecosystem moves faster than maybe it would otherwise. And one thing I really like about Clojure is that there is no binary compatibility hell, as in some other languages, including some JVM languages. Binary compatibility hell for you Ruby people is when a new version of a library comes out, of the language, of the compiler or whatever, and you have to recompile all your stuff for it, or you will be hitting crazy issues. So there is one very nice programming language on the JVM that is known for, you know, breaking every single release. I won't name it because this talk is not about that language, but yeah, it's not something I want to deal with because you can imagine how much work that takes. Many active Clojure developers are very conservative with versioning, maybe sometimes too much, and calling things done. So if you see versions like 0.0.1, Unfortunately, sometimes that's actually a library that's a year old and is pretty good, and you actually can use it without fears, but the fellow who develops it is like so conservative that it is, yeah, a little ridiculous. And the entire story fits the JVM ecosystem maturity very well. So, the real reason why Clojure is so stable is because it's a small language. If you think about, you can talk to JRuby developers about how many crazy edge cases Ruby has, and you don't really think about that, but it's nuts. How many little things that hurt execution performance, that produce bugs that people then rely on and assume normal behavior, and then when those bugs fix, things fail, people blame, I don't know, library developers and stuff, and yeah, it gets ugly. There is no monkey punching. Well, technically there is, but I didn't tell you so. There are features that give you all the good parts of monkey punching without all the crap that comes with it. Like, you know, I just loaded a library and now my entire app doesn't start. Like, raise your hand if you had that experience. Yeah, that's pretty cool, right? Again, backwards compatibility story in the Ruby community. Shame on you. So, consistency is another thing that I really like. And in particular, you work, because it's a functional language, you work with collections and sequences a lot. And there are obviously multiple implementations of collections, like sets, vectors and stuff. And you use the same functions to work with them. And Clojure compiler, well, does things reasonably smartly, and you don't have to worry about the exact, like, is it a set, or is it a vector, or is it a lazy sequence that is even infinite, like an audio stream or something like that. So that's really great. It lets you focus, doesn't get in your way. You can implement your own data types that work and look and feel just like Clojure core data types. Again, you don't typically need that, but sometimes it's very, very nice, because if you think about it, something like a cache, well, it's the same thing as a hash or map, right? It's exactly the same thing. It's a key value store that may be in memory or maybe not. So why not implement a caching layer that behaves exactly as Clojure maps? It just makes sense to me. And that's what, there is a library like that for Clojure.cache that does that. Because Clojure is relatively young, I mean, it was released to the world very late, in November 2007 or so, but really people started, someone discovered it maybe at around 2009 or so, something like that. There is almost no baggage in the core language. Let me explain. So what happened is that Rich Hickey discovered most of the stupid things he did in the first version before other people did. So he fixed them. It's now you don't have to deal with that crap. Whether some other languages now carry a huge amount of basically old stuff that you cannot throw away because people depend on it, but everybody agrees that it stinks. Like, how many people love Ruby's built-in HTTP client library? How many people find it stable? How many people think that it makes sense? Okay, why are there 20 other Ruby HTTP libraries? Maybe the one in the standard library actually isn't that great. And again, repeating myself, but Clojure was actually designed, and I think that's why it's consistent. There is no secret. So what does deployment look like? We have a shiny Clojure app that is consistent, has excellent runtime performance and stuff, but we probably want to deploy it at some point. It's a pretty standard JVM deployment story. So my favorite option is to just compile everything into a single jar, called in the Clojure community called Uber jar, that includes all your dependencies. So everything, all the libraries go into a single jar. You can add any files you want there. So I don't know, some people include things like, well, CSS is not a very good example because I personally haven't used Clojure for web parts, but if you want to, you can include anything you need and then load it via standard library at runtime at least that. So once you compiled everything to a single jar, you can use a tiny shell script plus a Debian tool called Start-Stop Daemon. I'm not entirely sure what the alternatives in the Red Hat world, but there definitely is something. And that's it. And you integrate all that stuff with your init system, and then you can also use Shadow Strong for deployment. I think those options are pretty good. There is also something called Immutant, which has nothing to do with the title of my talk. And it's a Clojure layer / bunch of libraries on top of JBoss's application server. It's a pretty heavyweight stuff, but yeah, it has its place in the world, and it simplifies certain things once you have a bunch of applications. Because, well, primarily because it's standard stuff. You can deploy Clojure to Heroku, which is, I haven't used Heroku much outside of Travis CI. Yeah, so you can do that, just push and boom. You can deploy Clojure to Cloud Foundry with a library called Quad by Alvaro Videla, who you all probably know and love. So now our shiny Clojure app is deployed, and okay, it's running. So what the operations workflow is? Again, the usual JVM story: Visual VM, JStack, JHeap. There's something called NREPL. N stands for network, which means it's like remote IRB, if that makes sense to you. What that lets you do is you can run an NREPL on a different machine and basically execute stuff there, submit code there for execution, inspect your environment, modify it. It's actually, I think to you it makes sense because you can do some of the things with IRB as well, but another nice property of it is that you can integrate it with tools, so things like IDEs or Emacs or Vim, they don't actually try to build them at the runtime to do code completion and stuff. What they do instead, they send it over to a local process that does all the hard work and returns the result back. That's pretty neat. Another neat option is remote REPL over HTTP, well, HTTPS technically, on Heroku. So some people do that, they debug their stuff over HTTP on Heroku. It's not trivial, but yeah, some people do that. I know that lots of people on Heroku do that because they invented this stuff. So yeah, I'm telling you that you can debug shit over HTTP on Heroku. It's not quite Erlang, to be honest. People who work with Erlang, it's probably being a little bit skeptical, saying, well, whatever, we can do that. We could do that 15 years ago. That's true, that's not quite Erlang, but it's still ahead of most other languages. So there is something called Visual GC, which is a plugin for Visual VM. And it shows you basically in real time, or however often you want it to update, it gives you an insight into your garbage collection process. So what sizes of each generation are and how it changes over time, because this is what matters for tuning, and what is object depth rate and all that kind of stuff. It is really awesome, because I have seen cases where, well, you need to tune things, right? And yeah, it's a visual tool that lets you do that. I don't see how anybody would not like it. So JVM supports dtrace environments where dtrace is available, so which is hilarious, Warriors FreeBSD and macOS 10, although OS 10 it is a little bit crappy. But yeah, it's useful enough for many things. And then, as I mentioned, there's something called btrace, bytecode trace. Unfortunately, someone needs to write a good blog post about btrace because most people don't know about it, but it is very helpful as well. You basically write your probes in Java, which sounds like not very fun, right? But first of all, it's nice to have this option. Second, you really don't need much code to benefit from it. So, a few people yesterday asked me about to include the community section, so okay, let's do that. It's full of intelligent people at this point who actually know what they're doing. It's a relatively rare thing according to my experience, so that's pretty good. I mean, at some point it will be diluted by, people who know a little bit less, but at this point, it's pretty great. There has been 4 conferences to date, and the 5th one, Clojure Conch, the 3rd year, is coming this November. So if you're in November in the States, maybe you can get, maybe not, I'm not entirely sure. There are about 7,000 people on the mailing list, which it's fewer than with some others, but surprisingly more than I thought it would be. I would expect it to be, I don't know, a couple thousand. And the mailing list is very active, so if you have questions, usually it's a good place to ask. So again, I'm not going to go into too much detail about users and stuff because it would just take too long. But yeah, it is used by small companies and huge corporations, not just in the financial industry, but for some reason it is taken off there surprisingly quickly. And one thing I can tell you that there are many companies that don't really publicly speak about their use of Clojure for whatever reason, but it's known that they use that. For example, at one of the, I believe at the last Clojure Conch, there were a dozen, yeah, there was a dozen of people attending from a little company called Apple. Of course, we don't know whether Apple actually, what do they use besides Objective-C and Cocoa, but I mean, if you delegate a dozen of people to a conference, you probably have some interest, right? Or your engineers just, want to go around every conference possible. So another thing is that Clojure is fun to work with, honestly. I don't know about many other languages, but my background suggests that, yeah, I wouldn't say that Ruby is that much fun to work with these days. Maybe it's just me. Clojure profoundly changes the way you think. And it's not like, it's not drugs, it's not hard liquors, but it definitely changes the way you program, and it opens a lot of perspectives, I would say. Yeah, so let's take a step back and look at how exactly it changes the way we think if it's not a drug. It changes your perception of how do you manage your program state, because a lot of what our programs do, they change program state, right? That state may be shoveled in and out of the database, but still, it's just state management. That's the key thing in a lot of modern software. It changes your perspective on how to use immutable values. That's another thing that few languages will really teach you, and it is, I will get to it later, but it makes a huge difference with respect to concurrency. It changes the perspective on the value of experimentation, because a lot of the Clojure ecosystem either integrates with or just is built around using REPL, so people use it a lot. I spend a non-trivial percentage of time developing things in the REPL, and then I evaluate them. Well, in Emacs it is called a buffer, in other things it's like a document. And you can do that from Vim, from IDEA, from Eclipse, from, I'm not sure about the NetBeans plugin, but probably you can do that too. And obviously Emacs is something that, it's an excellent tool environment for this kind of program. It's really great. It's a shame that other communities do not encourage it as much. It changes your perspective on metaprogramming, which means that you grow up, basically. So what does that mean? Well, first of all, you don't abuse it, which I think is relevant to Ruby people. And another thing, you also understand that Ruby actually has very good metaprogramming story, I would say. But Clojure and any other homoiconic language gives you a lot of extra power when you need it. So that's pretty neat. And again, I'm not going to talk about how Ruby and Clojure metaprogramming techniques differ. There is quite a bit of difference, but it will affect your perspective. It changes the way I think about isolating side effects. Clojure is not a strict language. It, in fact, doesn't really enforce that much on you, except that, well, data structures are immutable, so you have to work within that reason. But other than that, yeah, Clojure won't ask you to jump through crazy hoops and write 85% of your program up front, and only then add a little bit of logic at the end, and well, hopefully it runs. So yeah, side effects are, you probably can read anything on this stuff, but side effects, they can quickly get out of control. And so just anecdotal evidence, not yet. So program is what? It's pure core and parts that communicate with the world, right? That put stuff in a database, take it out, render something, send something over a socket. Use asynchronous I/O. Yeah, so, but the pure part is always there in every program. So what that means is, if you just pay a little bit attention to it and make larger percentage of your program to be pure, it will be ridiculously easy to reason about, to test, to explain, to understand, to optimize, and so on. It's a very, very good thing, but yeah. A typical Rails app, 99% of methods have side effects of some kind. Well, maybe not 99%, I can't believe it is over 85 or something like that. That's not really something to be proud of, because reasoning about a code that is almost entirely side effect based, it's pretty crazy. And that's why you have things like that were mentioned in the talk yesterday about once you start adding concurrency to your program, boom, it turns out Ruby doesn't have a great concurrency story. It's not about runtime. It's about the awareness of the ecosystem, of people, of libraries, and so on, about the fact that, things are getting a little bit more concurrent these days. And you have to adapt to that. So a typical Clojure app, or a typical means, well, what code bases I have worked on, and people who basically answered a bunch of my questions about their rates, it's like 40% of functions have side effects. Maybe a little bit more, it really depends on the app, because basically in the finance world, a lot of stuff is, well, built around math, right? Or inventing crazy Ponzi schemes, which is also based on math. And yeah, you have very few side effects there, but I still think it is significantly lower. Clojure encourages that kind of programming, but again, doesn't force you completely, doesn't force your hand. So again, anecdotal evidence, I spent 3 to 4 times less time on tests, which again, for me, is maybe 60% of my work time. It used to be the case in Ruby. So that's a pretty great reduction. Now you have 60%, well, not 60, but okay, yeah, I obviously can't count. Now you have up to 75% more time to work on something else, or hopefully on something that matters, or on reading hacker news. The moral of the story is, make more of your code not have side effects. You can do it in any language. You don't have to jump through the hoops to do that. You don't need a special language. You don't need special tools. You just need discipline. And discipline is hard, right? Well, that's a great story about Clojure and many other languages. So it profoundly changes the way you think about all that stuff. What else? It motivates you to learn. It is very concise, terse language. You don't, if you want to like say, okay, do this and that, it usually doesn't take a lot of boilerplate. In fact, most of the rules are already invented in either Clojure core or the JDK. So if you find yourself thinking about, there should be a function that does this and that, almost certainly there is. You just need to find it. So, because it's stable, you have fewer distractions. And what it really means, it lets you get in the flow, the psychological concept of flow. When you're just, go crazy and write crazy awesome stuff in 1/10 of the time. It doesn't happen to engineers very often, but something that helps you get in the flow is invaluable, I think. REPL-driven development helps you stay in the flow for longer periods of time, which again is relatively unique if you come from like Ruby and Java background. Clojure has polymorphism done right. So polymorphism, if you have a particular function, let's say count, whatever you give it, maybe a set, a list. Obviously, implementation of sets and lists is very different internally, but you still use the same function to work with that. This is really awesome because there are other languages that I was considering that don't have that. It leads to crazy amount of boilerplate code that it just stinks. This is a quote from the book called The Joy of Clojure, which is a great book, but is not for beginners, I would say. So Clojure demands that you raise your game and rewards your great report. So yeah, you have to learn new things, you have to man up and control side effects a little bit to really benefit from it. You have to live in a world of concurrency where values are immutable, but that helps a lot. It has a lot to offer in return. Yeah, again, I probably didn't edit my slides very much. The community is full of smart and actually very down-to-earth people. You want typically, if a newcomer comes like in the RC channel, usually people are more helpful than in many other communities, and there are interesting things that come out of this, like they have REPL right in the chat room. So people basically evaluate stuff in the chat room. There are two bots that do that. Because JVM has a very good sandboxing story that's safe, so you can't completely take control over that machine. It's a pretty great idea, actually. If you want to show something that, hey, here's how it works, you don't have to go to gist.github.com and paste there something. You just do it in the REPL, because many things are one-liners. Well, in Clojure anyway. Yeah, what else? Other things. So Lightning is a Clojure build tool. It's like Ruby gems, bundler, and something else all in one. Because it is a single tool, it actually can offer you things like deployment. That's something that I was talking about. You compile everything to a single jar using Lightning. You don't need to invent anything for that. It's done. Yeah, and it just works typically. It's very straightforward. I use it for some Java pieces. Again, very happy with it. It's pretty great. And if you want to write like a custom task, it is as simple as writing a Clojure function. I mean, pretty cool. Not some, DSL that is no longer maintained, called rate. So dependency management, build tool, custom tasks are all, those things are no longer need invention, and Clojure just borrows good ideas and has them in the tool chain that everybody uses. It's very widely adopted. So it packages your code into a single jar for deployment. Lightning makes it trivial to develop against multiple Clojure versions, which is great because, for example, all my libraries I hack one are tested against 3 Clojure versions. One of them is nightly snapshot. So you typically see bugs way ahead of time, while say in Ruby, you typically have to either compile it every day and try your stuff out on it, or you have to just pray that in the next Ruby version things will work, and sometimes they don't, right? There is something called Clojure, which is like rubygems.org basically. You deploy there via SSH or TCP or HTTPS. HTTPS support is not completely finished yet, but yeah, once that is done, to deploy a new release of the library, it's like 2 lines of code in the shell. It's because it's very easy to deploy snapshot releases. Every time I fix a bug in the library, I publish a snapshot and tell people in like the issue thread, hey, here's a new snapshot, use it, and your issue will be fixed. So you don't have to wait for me to do a release, which I may do, several weeks later, to benefit from all the new stuff. It's very convenient. This is actually not the Clojure thing, it's just how the JVM ecosystem works. Clojures in Line Engine are maintained by the same core team, which is great because you obviously can integrate them. Travis CI, which I'm a core team member of, supports Clojure, and you can test against multiple JDKs, again, pretty sweet stuff. The ecosystem, I would say, just by the feel of it, it's probably a lot like Ruby around 2007. I'm not sure how many of you have been around. By the way, how many of you have been using Ruby in 2007? Oh man, lots of new faces. Well, that's good. Yeah, I feel old now. But the difference is that you have the entire JVM ecosystem at your reach. You have all the tools. Yeah, sure enough, IDEs is not as great as Java's, but they're still pretty great. I think Eclipse is the most advanced one. I don't use that, honestly. You have all the tools, you have all the libraries. People who have to deploy your stuff understand they exist in runtime, while if it has been something like completely new, developed from scratch, it would take some learning and, skepticism. We want to deploy that new shiny code script or whatever. So, Lightning and Clojures make it possible for people to very quickly publish libraries and add libraries as dependencies. So if I publish a library, something can begin using it, even if it's just a snapshot, it's not, released by any means, it actually can already be used. And what it means is it encourages people to publish libraries, and many libraries are pretty small, do one thing, but do it hopefully well, and yeah, that's a thing of beauty for me. The ecosystem more than doubles every year. Honestly, it's hard to tell how you can measure that. But there is something called the State of Clojure survey. It has been running for 2 years by now, I think. And that it helps people to give the authors of Clojure and just the rest of the ecosystem an idea of what's going on out as a stuck out. So if you just Google for the State of Clojure, you will find it. So according to that survey, 35% of people come from Java background and 35% of people come from like Ruby or Python, which is pretty interesting. I probably wouldn't expect it to break out like that, but it does. And to me, it suggests that probably both camps find something appealing in it. Not just just Java people, but just Ruby people. The ecosystem tends to build libraries, not frameworks. I understand that maybe it's difficult to explain to a Ruby developer what the library is, because everything in the Ruby world is a framework. And if you have Objective-C trauma, that's probably completely foreign to you, right? Library is something that you can use without dragging a lot of shit in. And framework that basically says, okay, you can use this, this, and this, but you also get a pile of this stuff. Deal with it. So yeah, maybe there will be frameworks at some point. People haven't shown much interest so far. So there are 6 books published about Clojure. 2 of them unfortunately are outdated. Well, one has a 2nd edition. The one I recommend is Clojure Programming by Chas Emmerich and 2 other smart, Christoph Grahn and 1 other smart person that I don't remember the name. It's a great book, and it's like $25 on Amazon. I don't know, they have a Kindle edition, so. So it sounds all shiny, right? But it can't be like that. Not in a year of usage. So what sucks? I really hate Clojure.org, meaning the site. It's not taken care of very well. Fortunately, that hopefully will change soon. There is nothing to announce, but it will change at some point. There is enough interest from all kinds of people to do that. Documentation kind of related to that. Guides are badly needed because books are great, but books tend to cover a lot of ground that once you begin working with the language, you no longer care about because that's just trivial stuff. And you need something that is in the middle. Like there is a lot of information for experts, there is a lot of information for beginners, and people in between, basically, they are suffering. This is, by the way, is true about the entire open source ecosystem. For the most part, that's how it is, and that's very, very sad, in my opinion. So compiler messages can be cryptic. It's certainly not, previous versions of Erlang, but it can be cryptic in the way that sometimes you do need to understand the JVM a little bit. It's not like it won't dump bytecode on you, but yeah, you need to know what an interface is, for example, in the JVM, because if you don't, Clojure or any other JVM language probably won't be very helpful. So JVM startup and code compilation that happens is annoying if you want to run tests all the time in the shell, as opposed to like REPL and other special tools like Drip or Nailgun. Unfortunately, it won't change very much until like JDK 9 or JDK 8 shoots next year. 8 is better than 7 in comparison, but still, nothing to write home about. The contribution process sucks. Clojure uses a fine-crafted 16th century contribution process when you send letters to foreign countries, to Durham, North Carolina specifically. It kind of not very convenient because to contribute a tiny patch that maybe one liner you have to wait for 2 months doesn't sound cool, right? This Clojure contribution process is really vintage shit. Come on. So let's talk about something else. So obviously I have been using Clojure for close to 1.5 years or something like that. And I'm a pretty active open source contributor, so probably you can guess that I have a library or two. So let's talk very briefly about that. So there is something called Clojureworks, which is, we call it a growing collection of open source Clojure libraries. And for people who use them, often add that just works. Sorry for my German. So we pick modern targets, so Clojure 1.3 and later in JDK 6, although most people probably run 7 already in Clojure 1. By the way, Clojure still supports JDK 5, so if you're in an environment where you need to run JDK 5, you are all set. We try to make libraries feature-rich, which means, like, for example, our Elasticsearch client, there is only one feature it doesn't support, and that feature, I don't know anybody who uses that. So, documentation is my favorite feature. We care about it a lot, so check it out. It was written for you, for users, or potential users. It uses the same license. The Clojure community is almost complete, entirely uses the Eclipse public license, which is BSD style, or Apache style. We test stuff against 3 JDKs, and that's where you get all that cool stuff, right? So write it down. We really use a lot of Java libraries because, well, why reinvent the wheel? That's the entire philosophy of Clojure. Some of those libraries actually happen to be officially supported, so stuff like React and Rabbit and Vue Java clients. I basically just provide convenient APIs on top of that when that is even necessary. Usually officially supported libraries, with the exception of MongoDB, they are not shit. You can rely on that. So this is a quote, kind of showing off a little bit, by a happy Neo4j client user. What else? So the takeaway, let's sum it up, right? Clojure, one thing I haven't mentioned once in this talk, that Clojure is a dialect of Lisp. The reason for that is that there is just a lot of merit on itself. You don't really care about it 2 days in, and actually many people don't care about it at all. It is ridiculously stable, which is probably my favorite feature, and I wish all software was like that. Two other pieces of software that I can compare this stability to are PostgreSQL and React, which I don't know about you, but to me it says a lot about Clojure. Hosted or symbiotic languages is a great thing. It is ridiculously easy to get started with them in the way that you don't have to reinvent wheels. Again, awesome. No need to fear the JVM. It kind of has a little bit of bad rap in the Ruby world. I don't completely understand why, probably because not that many people actually tried it. A lot of that reputation probably comes from Java EE, which both kind of have been evolving over time. Well, you know, it's not that heavy rate, and it's a giant ecosystem. There are all kinds of people doing all kinds of things. So immutability is essential for sane concurrent programming. I hope you agree with that. If you don't, well, you will learn it over time. Clojure greatly rewards people who choose to use it. Yeah, but the real reason is actually not all that, right? There has to be something else. Why do I use Clojure? Do I want to look cool? Actually, no. The real reason is this. Yeah, what the hell is that, right? That's a lazy cat. Well, lazy cat, what does it have to do with the programming? Well, it turns out there is a function in the core, in Clojure core, that is called lazy cat. And well, some will say, yeah, it stands for lazy concatenate. But think about it. How can you possibly, not like a language that has a lazy cat. That's all I got for you. Thank you.